This is say not exactly but conceptual. There is a piston, there is a connecting rod, and there is a crank. Crank is not actually drawn, and if I move this crank, see the mechanism is going to work something like this. Getting? Now how to do it is very simple. See, it's not that much difficult. But instead of using regular dimension, we need to use parametric. See here there is a menu parametric. So now there is a difference in parametric and associative dimension. Parametric dimensions and associative dimensions. See, all CAD softwares are parametric, but AutoCAD is not parametric. It was not parametric unless there was released 2010. After 2010, now it is parametric, but generally we don't use it. So what is the beauty here? Generally in AutoCAD we need to give dimension first. Suppose I want to make this line exactly 100 units, then I will type 100 and put enter, and then again it will be 100. Now I want to change it. Cannot do it because it is associative, but in parametric you can do it. So what I need to do, I will give dimension here. See, we have two dimensions in home. We have dimensions here, annotations, and a parametric ma પણ છે. So I will use this dimension and will give dimension to this line. And now this is stretchable. See, if I put here 20, then it is 20. I can double click here and can change to 100, and the line will be 100. Why it happens? Because it is parametric. And first we need to fix this. So there is a lock here. These are called constraints. So all the softwares are having different constraints. Creo is working with 9 constraints, but AutoCAD is having these 4 plus 3, 12 constraints. Which are there? See, if you go one by one, coincident, then collinear. If you will keep your mouse there, it will show you a detail help even, if it is possible. See, is showing you 1 and 2, and some lines are also even written. If you go through that, you can immediately come to know for what this means. So it is coincident, then collinear, concentric, fixed, parallel, perpendicular, horizontal, vertical, tangent, then smooth, symmetry, and equal. Okay, we are not going to use each one. Very simple. So I want to fix it, so lock it and click on this. So now it is locked. Now the line will not move. Now what I need to draw, I will draw a line. See, this is connecting rod. So I will use this coincident button and will use, you put this end with this end. So now what will happen? If I move this, it will not come out of that thing. Means it is hinged. But see, the length is going to change. So what I should do, let us put dimensions here, aligned, and put this with 25 units. See, now if you move this, even it will not increase the change. After what happens, see, even the other line is fixed, is going to have some angle. So what first we'll do, we'll make this horizontal. See, in all conditions this line should be horizontal. So we have a constraint here, horizontal, and click this entity. Now again check what happens. Even see, line length is not going to increase. So crank has been done. Crank banegi. Now similarly, let us have a connecting rod. So first we'll randomly draw the line, and again we'll add this button with this, and I want to make this sliding. So we have another thing, collinear. So I will put end of this. It is not exactly matching there. Concentric means selected circles, arc, ellipses will maintain the same. Coincident points and coincident. Let us try again this with this. Now let us rotate this and see what will happen. See what happens. Connecting rod lambo thai, ama thai છે. It is stretched. So what we should do, again give dimension to that. Say aligned and give dimension to this. Let us make this say 90. Now let us check. But now this mechanism will not move. Why? You have given the constraint in such a way that this is not a mechanism, because if you keep this 90 to be constant and if it is attached from here, then it cannot work. So forcibly we have to delete this constraint. આને તમે અહીંયા lock ના કરી શકો. It should be moving. So again we'll draw this and we'll put this with this, and the slider is two lines or lie on the same infinite line. Two lines can be attached, but yes, let us put a rectangle here and define this as a block. Say piston, select object and convert to block. So this name is already there. Let us give another name, say piston 1 2. And now we'll actually we need to redefine. Again block is required to be redefined, so we'll select that piston 1 2 and again select the object. So it will ask for whether you want to redefine. Yes, redefine. So it is having itself reference is there. So first we need to explode. See, this is called knowledge. So again redefine the block, say piston 1 2, we'll select the object and say okay. Block definition which do you want to redefine? Yes. Now we'll move this circle to end of this, and now we'll put this let us realign. So second option, collinear, and we'll select this line to be collinear with this, and now we'll put this end of this to this circle, give dimensions, say 100. Let us try. Does it work well? Yes. Let us hide the dimensions, hide constraints and hide dimensions. Even you can increase the length, but let it be there. See? Now if you want a locus of any point, you have learned, no, in first semester you have done locus. Can anyone from you give me any definition? તમે લોકો engineering drawing માં કંઈક definition સ્લાઇડર ઉપર કયા ક્વેશ્ચન્સ હતા regarding engineering curves or locus of points? એવું કંઈક હતું? If I remind you, what will be the locus for this dimension of midpoint of this connecting road? So let me put here a point. Say here is a point. Now this slider is going to rotate here, and what will be the locus here? This is my analysis, or it is my interest. So how AutoCAD can help here? See, let us put this point first at the midpoint. So again I need to give constraint. This should be here. Now let us check if that point is moving with this and is at you. Now AutoCAD still doesn't have any option which will automatically trace the curve, which is possible with Creo, but AutoCAD it is not there કે ભાઈ આ trace શું થાય છે એ આપે, પણ આપણે અહીંયા કરવું છે એવું કે ભાઈ tracing કરવું છે. So what we'll do, we'll add one dimension here, again show all, and we'll add angular dimension between this and this. So at present is 60 degree. Let us make it 10 degree. So what is the locus of this point? Here. Okay, let us put one point here exactly because the other will move. હવે આ degree છે, let us turn this to 20 degree. So the point 1 is already there. This is attached with the mechanism. So you can have another point here. Again you change 22, let us have directly 60, and again you draw a point exactly on this. Likewise, let us make 60 to 90. So again you add point. થોડીક મજૂરી છે, but it will give you the result. 90 let us make to 180 and draw point here. Let us make to 200 and add point, and likewise you can do no. Let us hide it. So you have some locus starting from here. You can conveniently draw spline which is passing through these all points. So we'll activate node here. So this is the locus, and this will really solve many engineering problems. See, many times we don't know what can be the locus of that point so that the mechanism will function. Actually આપણે શું કર્યું, locus find કર્યું mechanism થી, પણ આપણો objective industry માં શું હોય કે આવું locus મારે જોઈએ છે તો મારે mechanism કેવું develop કરવું, and you can now conveniently give answer to that. You can reverse engineer this thing, and likewise you can be having exact analysis. Okay, now as I have done here, suppose this I want to add this schematic which is called a presentation part, then I can do it, but you need to switch over to convenient drawing. So first let me come to the original view, because we have given the dimension. Now we have to switch over by changing the dimension. Let us have 60 degree, અને આને આપણે અત્યારે delete કરી નાખીએ. હવે અહીં મારે કનેક્ટિંગ નોડ દોરવો છે, તો કંઈક પહેલા કનેક્ટિંગ નોડ આને એક્ઝેક્ટ સાઈઝ નું કરવું પડશે. લેટ અસ હેવ big end here and small end to be here. Now move those parts. We'll draw axis to axis thing, and randomly let us have this dimension, and we'll be having a fillet with this and this. Similarly, same fillet if we go with this, it will be larger, and we'll mirror this exactly center to center. Getting? Even you can erase this. Say this, there is a link. Now we'll create a block. Say link, select object entirely, and the block is defined. Now what we need to do, we need to switch over this thing to here. So again we'll use center is to be transferred to here. So what will happen if I move this, the other end will not move. Let us have this to be 90. અહીંયા છટકી ગયો ને, તો છટકી જાય because the relation is not given. Again give here, center of this should be exactly center of this. This is going to be over constrained somewhere. The concept cannot be, it conflicts with existing. So additionally it is having some concept. Block jara banana, maybe it has taken that. So in that sense it will exactly move something like this. Okay, now another mechanism we have is beam engine. See, it is something like this. Where it is used? Where beam engine can be used? જોઈને કેમ લાગે છે ક્યાં યુઝ થવું જોઈએ? Predict. Yes, exactly. હા, ઓછા લેવલ ઉપર ઓઇલ હોય તો ત્યાં this will function like see a pump. This is reciprocating pump, will produce some kind of vacuum here and oil will come up. આવું આપણે દોરવું છે. So how it is operated? See, there is a crank, say link 2. See, frame link 1 is fixed. Then there is a crank which is going to rotate. Another link is having link with this and this. So what will be the motion? Link 2 will be rotational or oscillating? Link 2 will be rotational. Link 3, you cannot say exactly, but it is not rotational, but it will function accordingly. Similarly, link 4, yes, it will rotate but not by 180 degree. And there is a piston rod, and this rod should be definitely oscillating, provided there is a cylinder here. So I have already drawn this. Let us check. See, is it અહીંયા તમે જુઓ, this piston should oscillate in a line. See, let us try to design this. Okay, how we'll start? Link by link. Say link 1. Link 1 should be fixed, so let us fix it. Link 1 should be horizontal, so let us make it horizontal, fixed. Okay, now there is a line or say crank connecting rod here. So we'll give this, attach with this, and we'll give align dimension so that it will not change. Let us fix to 70. So first motion has been achieved. Outcome થાય છે. Maybe again let us try to fix from this end. So first motion has been achieved. Let us go to that figure as well. આટલું થઈ ગયું. Link 3 will draw randomly. First put this somewhere at this distance and say here is a link. So again we'll give constraint from here to here, and it has been achieved. So if you move from this, the other is also at present there is no constraint at this end. Away. Now there is a vertical line, so also we'll draw here for reference a vertical line to decide the distance. First make this thing fixed and give dimensions. Say 175. Okay, now we'll draw link 4. Let us make midpoint fixed with end and give dimension. Say 250. Let us check the motion of this. See, because we have not given aligned dimension, so maybe the length is going to increase due to that. Why does it happen? Vertical nathi apu. Let us give this thing vertical. Make this thing vertical. Now let us try. See, at each point you need to check. હવે શું વાંધો છે? Size is going to increase. So we have not given the size. So let us give this size, align this to this. Say 230. Let us try. બરાબર? Thank you. See, this is link 4. So link 4 is conveniently going to rotate. Now we link this 3 to 4. So again we have this with this. Now let us try what happens with this. So size. Any size nathi api. Let us give this to align this to this. Say 150. Let us try again. કેમ થાય છે? See, this is now there is a concept. તમે આને અહીંયા સુધી લઈ જાઓ તો આ બહુ વધારે એંગલ આવી જાય છે. So being an engineer, what you will do? See, what choice you have? You have this dimension in your hand, this is in your hand, and this is also in your hand. So you have a choice. તો તમે એમ થાય કે ક્રેન્ક છે આને નાની કરવી સારી કે આને નાનું કરવું સારું? it is better to reduce this. So if we go to 50, then let us try. હજી આ જગ્યાએ વધારે આવે છે. So let us reduce this to 100. See, this is kind of trial and error. It is increasing or decreasing. I fix થઈ ગયું. It is locked. હવે લાંબુ થાય એમ નથી. So let us have undo with us and change this to 300. Now this will do. Now conveniently you have a road with this. It can be done. This part can be done. I want to show you which is very important to you. I think you have heard the term 4-bar mechanism. 4-bar mechanism can be conveniently done here. So let us go with that. One mechanism is already ready. See, let us try. See, it is locked somewhere. One line. Now you tell me what should be done. This is our base which will remain fixed. What I should do? Let us lock it maybe from mid. What then I should do? Horizontal. So make this horizontal. So first thing has been achieved. Second link will draw. What will do? We'll use first constraint coincident this with this. Second link you can draw conveniently. Also we need to give dimension to this. Say it is 200. Also you should fix this dimension as well. Say let us say it is 500. Now again coincident this with this and give dimension to that. Say 300. And the last link will put this point to be touched here and this to be touched here to here, and it will automatically even maintain the length. Now let us move this. So what is missing? Yes, this line length is not given. So again give line length, say 100. So now a mathematical equation is there, no? There is an equation. So you can put the equivalent link length in that equation and find what angle we are getting, and exactly you can match here. And let us now find locus here. Check, hide first, all dimensions, say hide all and hide all. If I move here, see it is locked. So mathematically you can prove, if you give exactly this link length which is already prevailing here, and if you put this in equation, you will find that it is somewhere it is locked. So how you can resolve this? વધારીએ, say 200. Try. It is locked here. So let us change this to 500. એટલે આપેલું થઈ ગયું. એટલે આમાં એ AutoCAD અહીંયાથી due to inertia what will happen? Suppose there is one wheel here and another here. What will happen? It is exactly prevailing in railway engine. So if you rotate this, the other will also. So this is a special case of 4-bar mechanism. It is 4-bar. So conveniently you can have those analysis with getting. So with these we are ending mechanism design.